All right, in this case, what we're going to do is we're going to come up with an equation of this line, and we're going to practice sort of how to come up with that. So the first thing that we're going to do is write our y equals mx plus b, which is called the slope-intercept form. Slope-intercept form. This is called the slope-intercept form of our equation of a line. And we call it slope-intercept form because m is the slope and b is the y-intercept. All right, so that's why we call it the slope-intercept form, because when you look at this equation, it's very apparent, it's very clear what the slope and the intercept is. And so that's why we call it the slope-intercept form. So when you hear slope-intercept form, think y equals mx plus b form. Okay? So here we go, we have a line. Right off the bat, we should know a couple vocabulary words about what this line is doing. This line, it's a straight line, so we can call it linear. If we're reading this line from left to right, do you see that it goes down? We're reading this line from left to right like we're reading a book. It goes down. So since it goes down, it's decreasing. Decreasing lines always have negative slopes, all right? And then lastly, even though it's a line, it's a straight line, it doesn't go through the origin. Do you see that? Since it doesn't go through the origin, it is not proportional. So another word we could use to describe this line is it's not proportional. Proportional, all right? If it did go through this, for instance, if it went like this, then it would be proportional. It's a straight line that does go through the origin in this case with this new line, and then you could call it proportional or directly proportional. Directly proportional and proportional are the same word, okay? So if you see directly proportional, you can just interpret that as being proportional. This means proportional, okay? So those are some of our vocabulary that we can always use with lines. But let's go back to our original line here, and let's come up with the equation of it. So the equation for a line in the slope-intercept form is where we need to find out what the slope is, and then we need to find out what our y-intercept is. So let's find out what our slope is by counting. I always recommend to use the counting method of finding out what slope is if you're given the graph. If you're given the graph, you can count the slope out in a matter of seconds. Using the algebraic formula for slope also works, but it takes much longer, and that's why I would only use the algebraic method if you don't actually have a graph and you're forced to actually use the algebraic method, which takes longer than counting. So let's count this out. So slope is the vertical change over the horizontal change of a line. Horizontal change. And I remember how to write the vertical on top and the horizontal on bottom, because horizontal is left to right, which is like the movement on the x-axis. And so the x-axis is sort of at the bottom of this graph, just like the horizontal change or the change in the x is on bottom. So that's how I can remember the x is on change is on bottom. The vertical change is the up or down change, and that is on top. So that's how I can remember always put the up or down on top and then the left or right on bottom, just like the x-axis is on bottom here. Okay, so let's start from one point and go to another point. And it doesn't matter which points you choose as long as they're both on the line, and it doesn't matter which direction you go. So let's go from here to here. Just because maybe you thought, oh, okay, the only way to do it is from here to here. I literally could go either direction, that's fine. So let's go here and try to get to here. Okay, our vertical change is going to be on top. So to get from this level to this level, since this level is on the x-axis, like at ground level, and I'm trying to get up to this level, which is like the second floor, I'm going up 2 floors in a building. So that is a positive change because it's going up. If it was going down, it'd be a negative change. Okay, now we're over here and we're trying to go back to this line, so we need to go to the left. Since we're over here, since we've gone up 2, here we need to go to the left. How many? 5. We can just count it out. 1, 2, 3, 4, 5. okay? Because this is 5. We were at 5 horizontally. Now we need to go this way. Since we're going to the left, it's a negative change. So it's a negative horizontal change, negative 5. So our slope is negative 2/5. And there's another thing I'd like to point out. This negative down here can be placed up here, or it can be placed right in front. So there are 3 ways to write slope that are negative. You could write it where the negative is on bottom, negative is on top, or negative is right in front of the fraction line. All of these mean a negative 2/5 slope. They all mean the exact same thing, so you can write it however you like. All right? So now we've gotten y equals negative 2/5, because we're going to place this where the m is, x plus b. We need to figure out where the b is. So the vertical intercept is where the line crosses the vertical axis. Here it's 0, 2. This point has coordinates 0, 2. The y value of this y-intercept is what the b is. This is what our b is. And the b is right here. So we see it's 2, and we put a 2 right here. This equation is a representation of this graph.